In this video, we're going to talk about transducers. Transducers have been used for many years on chillers and larger equipment, but now with the inverters getting into the residential market, you're seeing transducers being used on residential heat pumps and air conditioners. So a transducer is a device that screws onto the high side or the low side of a system and translates pressure into a DC voltage signal that tells the board what the pressure is that the transducer is reading. There are a variety of different kinds of plugs that plug into transducers to relay the signal back to the control board. When troubleshooting a transducer, the first thing you want to do is make sure that the plug is properly seated in the back of the transducer and it's sending the proper voltage to the board to relate the pressure. So on most residential heat pumps and air conditioners, you're going to find two pressure transducers, a suction pressure transducer and a discharge pressure transducer. Pressure transducers are dynamically assigned based on their relative values within the control board software. This feature allows the pressure transducers and harnesses to be interchangeable. Each pressure transducer requires three wires: the ground or black wire, the power, a 5-volt DC red wire, and the signal wire, which is green. The ratio of voltage between power and signal wires is converted into a pressure value. If the signal is above or below the pressure transducer's ability to measure, it may be because the power wire is not supplying 5 volts DC, or the signal wire is not returning a DC voltage between 0.5 and 4.5 volts DC. So in this wiring diagram, we see that the discharge pressure transducer is tied into P1 plug, and the suction pressure transducer is tied into P2. As we previously stated, these pressure transducers can be interchanged. So if you suspect one of the pressure transducers to be defective, by switching the plugs between P1 and P2, if the problem stays with the transducer, that means the transducer is bad. If it doesn't, then there could be a wiring issue that's going on and you're not getting the proper voltage through the wiring harness back to the control board. Here's a tech tip for you that we have found out in experimenting in the field, that these transducers can be bypassed. If you have a transducer that has failed and you can't get a transducer right away, but you want to keep the people in cooling or heating, you can bypass the suction pressure transducer or the discharge transducer by jumpering the transducer across the white and the red lead. Also, in troubleshooting the transducer, between the black and the white lead, you should have your 5 volts DC, and between the white and the red lead, you should have your feedback voltage of 1 volt DC. So with these pressure transducers, the high side and the low side, and with a suction thermistor and a discharge thermistor, we are taking pressure and temperature. And what does that translate to? It translates to suction superheat and discharge superheat. So without even putting a set of gauges on these units, we can now, by remote access, check the charge and the operating temperatures and pressures of the system without even getting into the system itself. Another thing you want to keep in mind, if you do have a defective transducer and you have to change it, these transducers may screw onto a port on the discharge or suction line, but in order to replace them, you have to realize there is no Schrader core behind these transducers. Most manufacturers do not put Schraders behind any safeties or pressure transducers that are on systems. So in order to replace a transducer, you would have to completely recover the entire charge out of the unit, replace the transducer, and then charge the system back up.
Go to arefco.com for more videos. Like, subscribe, and check back every week for new videos.